Today, the international scientific community continues to focus on Professor Avi Loeb of Harvard University and his ongoing research on the mysterious interstellar object known as 3I Atlas, a phenomenon that has sparked intense debate across the astronomy world. According to newly released data, 3I Atlas reached perihelion in October when it was exposed to solar radiation of up to 770 watts per square meter. Scientists are now questioning whether this intense heat and radiation could alter the object's physical nature or even reveal something beyond our current understanding of its origin. 3I Atlas had already surprised researchers with unusual acceleration patterns that don't fully align with the natural orbits of typical celestial bodies. Spectroscopic observations revealed a blue glow, suggesting either a unique material composition or a previously unknown reflection mechanism. These anomalies have inspired bold hypotheses, ranging from the possibility of a unique natural remnant to the far more curious idea that 3I Atlas could be an artificial structure created by an extraterrestrial civilization. The fascination with this object lies not just in the raw data, but in the way it blurs the line between science and the unexplained. Is this merely a cosmic curiosity, or could it be humanity's first accidental encounter with another intelligence? The latest analysis is opening a dramatic new chapter in our attempt to understand 3I Atlas. Observational data now suggest it exhibits an anti-gravity acceleration, behavior that cannot be explained solely by gravitational forces. Calculations indicate that if this is a natural object, achieving such acceleration would require 3I Atlas to lose up to 15% of its mass through vaporization, a scale almost unimaginable for a normal comet or natural celestial body. If correct, this implies the object has undergone a violent process, shedding not only its outer shell, but also a significant portion of its internal structure, offering humanity a rare chance to study the true composition of an interstellar object. Research teams expect to reach preliminary conclusions in the coming weeks about whether 3I Atlas is a natural comet or something else entirely. Yet, a more extraordinary possibility cannot be ignored. Some researchers propose that the anti-gravity acceleration could result from some form of propulsion, perhaps a rocket engine, an ion drive, or an even more advanced technology of extraterrestrial origin. This idea gained traction after post-perihelion images revealed at least 7 distinctly directional jets extending from 3I Atlas in multiple directions, including toward and away from the sun. These jets stretch for millions of kilometers. Preliminary estimates suggest those pointed at the sun are roughly 1 million kilometers long, while those pointed away reach up to 3 million kilometers, far larger than anything observed from conventional comets. Subsequent observations have further astonished scientists. The light jets from 3I Atlas are not merely optical phenomena, they appear to carry a density and energy level inconsistent with known laws of physics. Calculations show that one jet, aimed directly at the sun, must overcome the immense pressure of the solar wind, which travels at an average speed of about 400 kilometers per second, roughly 1,000 times faster than sublimating gases from a comet's surface. To maintain its structure over distances up to 1 million kilometers, the jet must be 1 million times denser than expected if it were composed of ordinary cometary material like CO2 ice. To sustain such evaporation, the absorbing surface area would need to correspond to an object at least 20 kilometers in diameter, far larger than the size originally estimated by the Hubble Space Telescope. This discrepancy raises another possibility. 3I Atlas may have fragmented, with the combined surface area of the pieces producing the observed intense evaporation. In the coming weeks, the fragments should separate under solar gravity, allowing scientists to determine whether the object is a natural decaying comet. This process could also help clarify the object's composition, shedding light on its true nature. Remarkably, Professor Loeb's preliminary estimates suggest that the total mass carried by these jets could reach up to 5 billion tons, an extraordinary figure that underscores just how unlike any known natural object 3I Atlas appears to be, an unimaginably vast number. If such energy and mass truly result from a natural phenomenon, then 3I Atlas may be one of the strangest cosmic objects ever discovered by humankind. But if it isn't, then we could be witnessing something even more profound, the physical manifestation of technology not born of Earth, a clue that science is cautiously yet eagerly chasing. Recent analyses continue to unveil new surprises about 3I Atlas, the interstellar visitor that has unsettled the global scientific community. If the object remains intact after passing perihelion, and its jets are confirmed to reach speeds of tens of thousands of meters per second, far beyond the expected 400 meteors of natural sublimation and comparable to the thrust of modern rocket or ion engines, then the idea of a purely natural explanation becomes nearly impossible. In that case, the energy required to produce such jets would represent only a small fraction of the object's total mass, perfectly aligning with the profile of an artificial propulsion system, possibly one powered by a technology far beyond human understanding. Experts emphasize that by accurately measuring the properties of these jets, their velocity, density, and chemical composition, we could soon determine whether 3I Atlas is a natural body or an engineered structure. The mystery is expected to unfold by December 19th, when the object makes its closest approach to Earth. Professor Loeb even remarked, half joking and half serious, that with Christmas just 6 days away, let's hope 3I Atlas doesn't bring an unwanted gift to our planet. A comment that sent a chill through observers worldwide. Recent amateur telescope images show a bright nucleus at the object's center, suggesting that 3I Atlas remains structurally stable with no evidence of large-scale breakup. However, astronomers haven't ruled out microscopic fissures or minor separations invisible to smaller instruments. Large terrestrial telescopes have so far been unable to capture direct images due to the object's close angular distance, only about 30 degrees, from the sun, making observation risky for sensitive optics. But as 3I Atlas slowly drifts out of this danger zone, hundreds of observatories across the world are preparing to turn their lenses skyward to obtain the first high-resolution images this week. Astronomers now wait anxiously, knowing that even the slightest deviation in jet velocity or structural shape could completely rewrite the narrative of 3I Atlas. Is it merely a freak comet, or could it be a controlled messenger from the depths of the cosmos? According to Professor Loeb, the answer is near, and it may redefine humanity's perception of the universe forever. As the scientific community monitors every movement, the coming weeks are expected to bring a major breakthrough in deciphering its true nature. Researchers predict that if the object has fragmented, its pieces will gradually separate under solar, gravity, and tidal forces, each fragment experiencing a different gravitational pull strong enough to tear them apart. Such a process would mirror the dramatic breakup of comet Shoemaker-Levy 9, which shattered under Jupiter's gravity in 1994. Leaving a brilliant chain of debris like a string of cosmic pearls. The question now haunting astronomers is whether 3I Atlas will meet a similar fate or reveal a process entirely new, perhaps driven by an energetic mechanism or artificial control. New images show 3I Atlas forming two distinct tails, one trailing behind and one extending forward in its path, the longer stretching an astonishing 3 million kilometers. Just months earlier, in August, observations from SphereX had recorded a faint gas cloud only 500,000 kilometers long, with no signs of such immense jet activity. By kinematic calculations, it should take roughly 3 months for a natural comet to form a 3 million kilometer tail at typical sublimation speeds of 400 km/s. Yet 3I Atlas displayed this phenomenon suddenly and unexpectedly, casting serious doubt on the natural hypothesis. To produce such a colossal tail in so short a time, the ejected material would need to reach escape velocities exceeding 1 to 2 kilometers per second, speeds far beyond the thermodynamic limits of cometary gases or dust. Even solid particles or ice crystals could not possibly move that fast. These calculations have left scientists in a profound state of confusion. Either 3I Atlas operates under an entirely unknown physical mechanism, or it is not a natural object at all. Though the final answer remains uncertain, one thing is now undeniable. 3I Atlas has shattered every standard model of classical astronomy. In the coming weeks, as it continues to move away from the sun and enters clearer observational range, humanity will learn whether this is merely an unprecedented cosmic event, or the first deliberate greeting from another civilization somewhere in the vastness of the universe. The latest data even show a slight orbital deviation due to microgravity acceleration, a shift roughly 10 times the diameter of Earth, still minor compared to the Earth-Sun distance, yet significant enough to remind us that 3I Atlas is far from ordinary. There is currently no indication that 3I Atlas is on a collision course with Earth, effectively ruling out any immediate risk. However, some researchers remain open to a more unsettling theory, that 3I Atlas might be a mothership, potentially launching smaller probes in various directions, perhaps even toward Earth. Though no concrete evidence supports this claim, the object's puzzling motion has kept the hypothesis alive. Meanwhile, astronomer Gennady Borisov, the discoverer of the 2019 interstellar object that bears his name, recently identified a new celestial body on November 2nd. Its orbital inclination, an extraordinary 110 degrees, lies almost perpendicular to 3I Atlas's trajectory. While this newly found body appears gravitationally bound to the sun and possibly originates from the distant Oort cloud, it isn't classified as interstellar, even though the two objects won't approach closer than 1 billion kilometers. The timing of the discovery, coinciding precisely with 3I Atlas's perihelion, has many wondering, is this merely coincidence, or could it be part of a broader cosmic pattern? Science remains cautious, but observers can't ignore how 3I Atlas continues to defy conventional understanding of the universe. Yet just as astronomers were preparing for high-resolution imaging from HiRISE to study the object, the data release faced an unexpected delay, caused by a U.S. government shutdown. Although the data itself is ready, the HiRISE team at the University of Arizona must await formal NASA approval before making it public. Unlike typical Mars imagery, this instance of delayed publication has sparked suspicion. Why, many ask, would 3I Atlas require such secrecy? Professor Avi Loeb voiced his frustration, arguing that bureaucracy is obstructing science. If released earlier, he said, researchers could have analyzed the data and refined their observation plans in real time. Every delay, he emphasized, is a lost opportunity for discovery. Loeb also criticized certain mainstream scientists, likening their behavior to artificial intelligences that merely recycle old data, clinging to outdated classifications and labeling every anomaly as a comet to preserve a sense of safety. Even when objects show no tail and exhibit zero gravity acceleration, he argued, they still insist on calling them dark comets, as was done with Oumuamua. According to Loeb, the real issue isn't just delayed data. It's science's unwillingness to abandon outdated stereotypes and confront the possibility that 3I Atlas may represent something far beyond our current comprehension. Meanwhile, the latest amateur telescope images of 3I Atlas continue to stir intense debate. Although not yet high in detail, many independent observations confirm that the object maintains its shape and steady trajectory, showing no signs of fragmentation. an extraordinary fact given the violent energetic events recorded nearby. Some researchers claim that if nothing unusual were found, NASA's image release would have caused no controversy. The delay, they say, only deepens public suspicion that something significant is being withheld. According to Professor Loeb, current data remains inconclusive, but the jets emitted by 3I Atlas cannot be fully explained through the natural comet model. He noted that it will take a few more weeks to obtain clearer imagery and refined spectral readings, which are expected by year's end. Loeb also clarified that the widely circulated figure of a 15–16% mass loss is only a theoretical assumption based on conservation of momentum laws, in which the speed of expelled matter matches the sublimation rate of volatile ices under solar radiation. However, if 3I Atlas isn't a natural comet but rather employs a technological propulsion system, such as an ion drive or an engineered jet, then the exhaust velocity could be exponentially higher, meaning far less mass would be needed to generate the same acceleration. Even a tenfold increase in exhaust velocity would drastically reduce fuel requirements. And if we imagine a civilization capable of achieving exhaust speeds hundreds or even thousands of times greater, the expelled mass would become almost negligible. Loeb explained that propulsion efficiency depends on the product of mass and velocity. The higher the velocity, the smaller the required mass. Therefore, if this is indeed an artificial system, what we observe could be only the faintest trace of an extraordinarily efficient propulsion mechanism. His words once again reinforce the daring hypothesis that 3I Atlas may not be a natural comet at all, but a technological construct operating on principles far beyond humanity's current capabilities. And as the world waits for NASA's long-delayed data release, the agency's silence has only added to the magnetic mystery surrounding what may be the most enigmatic interstellar object ever recorded. In the coming days, scientists will continue tracking 3I Atlas's velocity and trajectory to see whether it accelerates or decelerates against prediction. Professor Loeb noted that this reflects the true essence of science, observation before conclusion. He condemned the tendency of some institutions to suppress public curiosity, emphasizing that science must be honest, not protective. Comparing secrecy to a doctor concealing a terminal diagnosis from a patient, Loeb called such behavior unethical. Science, he said, must remain humble, guided by evidence, and free from information gatekeeping. At the same time, he confirmed an extraordinary revelation: the detection of a Mercat radio signal, the first ever recorded in association with 3I Atlas. The Mercat radio signal, recorded in South Africa, revealed two hydroxyl O absorption lines, a spectral signature usually linked to water vapor or oxygen-hydrogen compounds. Yet Professor Avi Loeb cautions that this doesn't necessarily indicate anything artificial. He believes the origin of the signal is more likely natural, not engineered. The phenomenon of the Mercat signal, in connection with 3I Atlas, has ignited a wide spectrum of interpretations, ranging from evidence supporting the cometary nature of the object to speculation about advanced extraterrestrial technology. According to Loeb, the current data is insufficient to draw any definitive conclusions. The detection of familiar molecules such as carbon dioxide, carbon monoxide, and water observed by the James Webb Space Telescope, JWST, since August 6th, only confirms that the object contains common cosmic compounds. These findings, while intriguing, do not reveal the true structure or nature of 3I Atlas. If the object is natural, Loeb explains, these molecules may be merely superficial. A thin chemical layer accumulated over millions of years while traversing the interstellar medium, rather than a window into its core composition. Observations prior to October indicated that only a thin outer shell was sublimating under solar radiation. But as 3I Atlas approaches perihelion, the surface gradually burns away, potentially allowing scientists to glimpse its internal structure, assuming it is a conventional comet. Conversely, if the object maintains its structural integrity while emitting jets at extremely high speeds in multiple directions, This could point to artificial propulsion technology. Loeb emphasizes that natural comets generally produce jets only moving away from the sun, driven by heat and solar wind. With 3I Atlas, however, some jets appear directed toward the sun, a phenomenon unprecedented in known cometary physics. This is why upcoming observations from HiRISE, when the object moves closer to Mars and enters an optimal viewing angle, are so highly anticipated. With its tilted perspective, HiRISE can capture the asymmetry of the jets, measure their brightness, speed, and directional spread, and reveal subtle orbital fluctuations. Loeb believes that within just a few weeks, armed with these high-resolution images, astronomers will be able to determine whether 3I Atlas is a disintegrating natural comet or a bright, purposeful object propelled through space by an unknown technology. Regardless of the outcome, Loeb stresses that this is a rare and vital moment for science, a return to the spirit of fearless inquiry, confronting phenomena that defy expectation. I think it's really going to be another 5 to 10 days before we know whether this thing is collapsing or simply a ball floating purposefully through space, he notes. As the observations continue to unfold, the global scientific community and the public waits in anticipation. Stay tuned for updates, and make sure to subscribe and turn on notifications to follow this extraordinary cosmic journey as it develops.